Salt is dissolved in water. Sugar is dissolved in water. But oil isn't. But grease is dissolved in oil. These are common incidents we get to experience in day-to-day life. But do you know why they're so? This could be explained by a popular statement in science. That is like dissolves like. Then how could we explain this? Stay with us until this video ends. Come and enjoy Arty Science, which touches the artistic places of science and makes people informed. We have to explain this phenomenon using chemical bonds. In this video, I'm gonna fetch you a clear explanation about chemical bonds and their origin. Through the next video, like dissolves like part 2, I hope to explain how the dissolving process takes place and what it is caused by, using the strength of chemical bonds and the theory of energy conservation. So what is a chemical bond? Between any positive and negative charge, it happens and attraction. And the basic substances such as atoms and molecules, which the materials are made of, are charged permanently or temporarily, being engaged in different incidents. So among these substances, it happens electric attractional forces. These are called chemical bonds. There are two basic types of chemical bonds. They are primary interactions and secondary interactions. The primary interactions are stronger than the secondary interactions. Why? You can come to know about this after learning the rest of this video and understanding the way these separate types of bonds get formed. There are 4 types of primary interactions. They are ionic bonds, covalent bonds, coordinate bonds, and metallic bonds. An ionic bond is born because of the attraction created between a cation and an anion. A cation is an ion charged positively. An anion is an ion charged negatively. It happens a strong attraction between these opposite charges. That's called an ionic bond. In a covalent bond, one or a few common pairs of electrons provided by both are shared between the two atoms. The covalent bond is formed by the attraction made by both the nuclei on the common electrons. You know that every atom has a positively charged nucleus and a negatively charged electron cloud. This electron cloud is attracted by the nucleus and held inside the atom. This affirms the consistency of the atom. Here both the nuclei attract the common electron cloud, and through this execution, they get bonded themselves. An ion is formed by interchanging electrons from one atom to another. So the quantity of sharing the electrons between the couple of atoms decides the ionic and covalent qualities of the bond. If that quantity is larger, the bond is considered ionic. If that is smaller, it's considered covalent. Nevertheless, every primary bond has both the ionic qualities and covalent qualities to their own extents. However, both the ionic and covalent bonds are rather strong because they take place between atoms. In covalent bonds, if the entire common electron cloud is provided by only one atom, we call it a coordinate bond. The metal atoms are comparatively larger in size. And as well, their valence shell possesses only a little number of electrons such as 1, 2 or 3. So the attraction made by the nucleus on valence shell is very low. So the outer electrons have departed from the atoms and roam freely among them. If two nuclei attract one electron, those couple of atoms get attracted through that electron. These are called metallic bonds. These are also rather strong, because they also take place among atoms. We can also discuss more complex information about the primary interactions. But this level is pretty enough to explain the process dissolving. Then we shall move on to the secondary interactions. The secondary interactions take place related with the molecules. There are 6 types of them. They all are commonly called van der Waals forces. Number 1, permanent dipole attractions. Number 2, hydrogen bonds. Number 3, ion permanent dipole attractions. Number 4, ion-induced dipole attractions. Number 5, permanent dipole-induced dipole attractions. Number 6, instantaneous dipole attractions, also called as London forces. Then let's consider how each of these attractions gets created. Number 1, permanent dipole attractions. What is a permanent dipole? Every atom bonded covalently owns an electronegativity, which refers to the ability to attract the common electrons towards itself. So the elements with high electronegativities get through to attract the common electrons towards themselves when covalently bonded. Then their electron clouds become rich. The electronegativity varies from element to element. So any heteroatomic molecule has a difference of electronegativity among its atoms. This difference of electronegativity between a covalently bonded pair makes a molecule polarized. In accordance with this difference of electronegativity, the atom with a larger electron density owns a partial negative charge, whereas the other owns a partial positive charge. This creates a dipole. The electrostatic attraction formed between a couple of opposite poles of different dipoles of different polarized molecules is called a permanent dipole attraction. Number 2, hydrogen bonds. This is also some sort of a permanent dipole attraction. The speciality is that one polarized molecule should have got one of the atoms fluorine, oxygen and nitrogen, bonded covalently with a hydrogen atom, and the other polarized molecule should have got also one of the atoms fluorine, oxygen and nitrogen. Why are these 4 atoms so special? The reason is electronegativity. Fluorine, oxygen and nitrogen are the elements with a very high electronegativity. Most elements with a very low electronegativity are metals, and they don't make covalent bonds. Hydrogen is the one and only element which has a low electronegativity and successfully makes covalent bonds. Therefore, the difference of electronegativity between hydrogen and one of fluorine, oxygen and nitrogen is so large. This causes a highly polarized bond. So the partial charges of these atoms become rather large. So this type of permanent dipole attractions are very powerful, and so that they are especially identified as hydrogen bonds. Number 3, ion permanent dipole attractions. There are some solutions including both molecules and as well as ions. So here, an ion could be attracted to an opposite charge of a dipole. This is called an ion permanent dipole attraction. Number 4, ion-induced dipole attractions. What is an induced dipole? There are non-polarized molecules in some solutions. An ion in the same solution is able to induce a dipole in this molecule. How could it do so? This is a negative ion, also called as an anion. And this is a non-polarized molecule. When these substances get close, the negative ion repulses the electron cloud of the molecule. So the electrons get closer to one covalently bonded atom rather than the other. This creates a dipole and makes the molecule polarized. Then the negative partial charge of the dipole gets attracted to this anion, and this is called an ion-induced dipole attraction. Number 5, permanent dipole-induced dipole attractions. Not only an ion but also a permanent dipole has the ability to induce a dipole in a non-polarized molecule. But that induction is not so powerful than that. However, between opposite charges of those polarized and induced atoms, there happened attractions. These are called permanent dipole-induced dipole attractions. Number 6. Instantaneous dipole. Instantaneous dipole attractions, called London forces. Consider a sample of non-polarized molecules. It could be either a uniatomic molecule such as helium, or a multiatomic molecule such as methane. Although there are dipoles in methane, they are invalidated each other according to their directions. Although they are non-polarized, when we make this sample colder and colder, the gas starts to condense and it converts to a liquid. Then what can we understand? Even among non-polarized molecules, there are attractions. Then how do they get created? The electron cloud of an isolated atom or molecule consists of the electrons which move randomly around the nucleus. For an instant moment, its symmetry could be broken as the electron density of one side of the atom or the molecule should be larger than of the other side. This occurs when the majority of the electrons gather at one side. This happens time to time very rapidly, and so that almost always instant dipoles are created. The opposite charges of these dipoles get attracted, and these bonds are called London forces. These dipoles are called instantaneous dipoles, cause they are induced without the help of any other substance. Okay, now you know what the bonds lasting among the atoms and molecules are. Then we have to explain the process dissolving using the strength of these bonds and energy conservation. I'll bring you that discussion in the next video, like dissolves like part 2, mechanism of dissolving compounds. Take part in that video for sure. Thank you for watching this video. If you gained something from this video, don't miss to like it and share it. Subscribe my YouTube channel for more video like this. Click the bell icon for getting a notification about my channel. See you again.